Hi, so my name is Sarah. I'm undergrad at North Carolina State University, and this summer I worked in the GOR lab with my mentor, Sam Herr. So nitrogen loss is a huge problem for maize systems, costing farmers billions of dollars each year in terms of nitrogen fertilizer and also costing the environment, as nitrogen runoff can lead to eutrophication and other environmental issues. So how to reduce this nitrogen loss in maize systems? Most of these nitrogen losses occur when nitrogen is in the form of nitrate, it's less stable in the soil, and nitrate is produced in the process of nitrification, where microbes convert ammonium to nitrate. And so after a maize grain harvest, there's this abundant resource of stover, which is the leaves and stalk left over. And a major component of the stover is called lignin. And when lignin decomposes, it produces these compounds that are known to inhibit nitrification, making lignin a potential solution to this nitrogen loss. So this project aimed to assess how lignin content in maize stover impacts nitrification, and also how genomic prediction models can predict lignin content and composition in maize stover. So to determine how lignin content is impacting nitrification, we performed a 4-week soil incubation experiment using 3 different maize genotypes of contrasting lignin content: wild type, BM2, and BM3. Our soil respiration results confirm that lignin is impacting microbial activity and thus the decomposition of stover in the soil, with our low lignin genotype having the greatest respiration overall. However, this didn't lead to any measurable differences in nitrogen dynamics for this experiment. For our genomic prediction experiment, we obtained data of the lignin content and composition for 347 maize hybrids. And then we found that both lignin content and composition, which is the ratio of lignin's monomers, have moderately high heritability and variation, as you can see with these graphs. We then performed a 5-fold cross-validation using 2 genomic prediction models, phase B and GBLUP. And lignin content was able to be predicted by both models with moderate accuracy, but they were not able to predict lignin composition with high accuracy. So in conclusion, genomic selection can be used to breed for lignin content in maize stover to enhance stover-based products. And also, while lignin's impact on nitrogen cycling is not known, it does have an impact on carbon dynamics, which can be used to influence soil management decisions.
Thank you so much for sharing your research. I love how enthusiastic you are about this. It's very clear how interested you are in this, and that's really cool. I was wondering if you could tell me, what was your favorite part of doing your REU this summer?
Yeah. I think my favorite part was just learning so much new stuff. I learned how to code for this first time using R. My favorite actual experiments was measuring the soil respiration. We used a electrical conductivity probe, and that was just my favorite part. But even just the interactions with all the people I was working with and all I was learning was a great experience. Thank you.
I'm so glad to hear that you had a good experience this summer, and it's clear it paid off. Great. Thank you.